everyone. Welcome back to the Virtual R Workshop series. This is the third R workshop, and today we'll be taking a look at data input and output using R. All right, as we usually do, we will look at our learning outcomes. So first, we would like to explain how to create a GitHub repository and collaborate with others on the same R projects, effectively load and look through built-in datasets in R, import the various types of data into RStudio, scrape data from the web using SelectorGadget and RVest, and finally, export and save the output data to your local computer. All right, so there's a lot of mention of GitHub in these learning objectives, so I would like to talk about that now. So GitHub and an application called Git fall underneath the branch of version control. So what version control does is it allows for multiple people to work on a single project at the same time. It can automatically manage combining or merging of all of your working files together, and it can automatically create historical versions of your project. The best way I can really relate to this is by comparing Google Docs and Microsoft Word. So if you are working on a Microsoft Word document, you type up your paragraph, you save it, and then if you want to work with somebody else, you will email it to them or send it to them. They will work on it, save it, and send it back to you. So this, it can take a long time, and you can't really both collaborate and work on the same document at the same time. So Git and GitHub is very similar to Google Docs, as in with Google Docs, you can both be working on a file at the same time. You can kind of see each other's changes. And if you're both working on the same line or something, Google Docs kind of handles merging all of your changes together and creates versions of your project. So that's probably the most real world use case that you guys have worked with. So in this diagram here below, it's just kind of a broad overview of how Git and GitHub kind of works. So you have a main application stored on a server, which is called the repository. And then each copy is sent to each computer. In this case, we have 3 computers working on something. And you can use different functions like commit or update to pull or send the files. So I want to show you kind of how Git and GitHub can work together. So at the very bottom is going to be your local computer. Your local computer will communicate locally with Git, which needs to be installed on your computer. Git will then communicate remotely over the internet with GitHub. So GitHub is just going to be storing all of your files and will be handling all that versioning remotely in the cloud. So this is really nice for remote backups and just having versions. All right, so why do we want to use Git and GitHub? There are other options out there, so why these 2 services? First of all, Git and GitHub are both free for personal and more recently for team use. It's a great way to share code with possible employers. When employers see a GitHub link on your resume, they'll kind of know that they should look at it and they can get an idea of some of the programs you have created. It's also a great way to share and collaborate with code. So let's say you see a nice project on GitHub and you're like, hey, this is kind of interesting, I'd like to work on it. You can actually clone that or essentially download it to your machine, and then you have that program running on your machine and you're free to make changes to it. And lastly, we use Git and GitHub simply because they're the most popular. You can see on this chart below, it kind of compares questions on Stack Overflow between the different version control programs. And as you can see, SVN or Subversion was popular kind of before 2010, but after 2010, Git really took the lead and has skyrocketed in popularity. So on a lot of job applications, you will see people wanting knowledge of Git and GitHub. All right, so let's jump out of this. And we have some preparation we need to do for today's workshop. So if you could please visit the link, the GitHub link that will be in the chat right now. Let me navigate there as well. So this is not the one. We want the R workshop 3_data. And now if you could please click this green code button with the little download icon next to it and click download zip, because we don't have an ability to clone, or we don't have a GitHub desktop installed yet. So we'll click download zip, and you will be taken to your little download menu. And I'm just going to save this on my desktop for now. So I'll click save. And we will get back to this in a minute or two. So we can actually open up RStudio now and get to creating a project. So I'll just open up RStudio. Let me close out of my old projects. And I will create a new project. I will go File, New Project. We've done this a few times before. So I will click New Directory because we're starting out fresh, and then New Project. And the directory name, or our project name, I'm just going to put R Workshop 3. And I will just save it on my desktop. So I will click Create Project. R in RStudio will do its thing. And in the lower right-hand corner, you should find your .r project file, meaning that you successfully created a project. And now let's create our script so we can actually program. So I'll go to New File. So I'll go to File, New File, our script. And I always like to type something just to be able to save it. So I'll click Save. And I'm just going to call this R script 3. And you can name it whatever you would like. So I will click Save here. All right. And now we have our rscript3.r script file. So we are doing good. So we are going to be working a lot with data here. So I want you guys to be able to have that data folder in this project directory here. So R in RStudio, when they're looking for files, they're going to look in something called your working directory. So that's just where R in RStudio will kind of look for any files that you mention here. So we actually want to get our data folder to appear in RStudio. So what we'll do is jump back to the desktop. And now I have my R Workshop 3 folder, and I'm going to open that up. And I have my R Script 3 and R Workshop 3. So if you notice, that directly mirrors what is in RStudio in the lower right-hand corner. So what we can do is go back to that file that we downloaded earlier. It should be called R Workshop 3 Data Master. So we can open this up. It is a zip file, so we will have to unzip it. But you can open it up and navigate down to this data folder. And for me, since I have 7-zip installed, I can just drag this data folder into my R Workshop 3 folder. So I will do that. It will take 1 second. And now if I jump back over to RStudio, notice I now have a data folder. So this is a nice way to store data in your projects. It can get overwhelming if you have just tons of files in this pane. So it kind of makes sense to organize them into a data folder. But now R and RStudio are going to look through these 3 files when we try to mention anything. So it's only going to look through these 3 files when we ask it to search for a file. So this isn't exactly what we want. We actually want it to look in this data folder for any of the files that we mentioned here today. So the way we can do this is by, I'll just delete this, is by going to Session and Set Working Directory. And then you can click Choose Directory. So I'm just telling R and RStudio, hey, this is where all of my files are. Please look here. So I will double click the data folder and click Open. And notice in the lower right-hand corner, it's now jumped into this data folder and 3 pieces of data pop up, or 3 files rather. And notice in the console as well, this little command popped up. It's called Set Working Directory and then wherever our data file is located. This piece of code, we want to save it. So I'm just going to highlight it, copy it, and include it somewhere in my script. We want to do this just so that every time you run the entire script, you tell R and RStudio, hey, my data is here. Please look for all of my files in this folder. All right, so now that we've done this, if R and RStudio know where to look for our files, we can actually begin. But first, we are actually using a lot of different libraries here today. So I think it's a good time to install a lot of these libraries. So if you look in the chat, you should get a fairly long list of libraries. We have a bunch here because we're dealing with a lot of different data types. So what you can do is highlight this entire thing and run it. So this makes sure that all of these packages are installed and that all of these libraries are going to be loaded up as well. So I'm actually going to comment all of these install commands out because I have all of these installed. And I will instead just highlight and run all of the library commands. It's good practice to kind of comment them out after you've ran the install, because let's say you're running this entire script, you don't want it to install every single package over and over again. All right, so this is going to take a minute or 2 on your guys' machines. So what I will do while that is installing for you all is talk a little bit about the built-in datasets in R. So what we can do to see all of the built-in datasets in R is by running this command. So it's going to be library and then help equals datasets. So you can actually run this command with all libraries, but we'll just run it with the datasets library here. So we can run it. A new tab will pop up for me, and it's called Documentation for Packaged Datasets. So you get some information about the package, but we mainly care about all of the different built-in datasets. So here you can go through and see what kind of interests you, but they're just nice for when you're beginning to learn and you just don't want to deal with importing any data. All right, so let's say you spot an interesting data set here. So in my case, it's going to be the MT cars data set. You can actually get more of an idea about it by running the help command again and typing in MT cars. running it. Let me actually move this up a little bit. There we go. So we ran this help empty cars command, and notice in the lower right-hand corner, it switches to the help pane, and we get a description about the data set. We get its name, the format, which is going to be all of the variable names. So it kind of gives you a better idea of the data set. And finally, when I'm getting an idea of a data set, I will also run the head command on it. And now I get to see just a sample of 6 data points and all of the variables. So from here, I'm actually able to understand a lot about the built-in data sets. So you can run these 2 commands for pretty much any data set built in, and you'll probably find something that works for you. All right. Hopefully at this point, everybody has all of their packages installed and loaded up. And so we will actually start importing some data from your hard drive. So probably the most basic way to import some data is going to be by reading in a CSV. So I'll demonstrate here, but there are many, many ways of importing data into R and RStudio. So I will show you a few examples just for importing CSVs, and then later on I will just show you one example for all of the other file types. So what we can do is run the read.csv command. This is the base CSV reader that is just built into R. So you should already have this ready to go. And the CSV I want to read in is actually going to be called students performance. We can see that in the lower right-hand corner here. So we need to put it in quotes, and we'll put, oh, if I could spell, students performance. And then you do need to include the .csv. And we will actually store this in a variable. I'm going to call it just base performance because we are using the base CSV function. So we can run this. And notice it appears in our data pane, and we can click it. And this is actually what our student performance.csv looks like. So that was the way to import it with base R. We can actually import it using the tidyverse version. So I'm gonna just call this tidy. So tidyverse is a large set of packages that's kind of like its own ecosystem in R. So instead of read.csv, the tidyverse version is going to be read_CSV. And if you notice on the highlighted section here, it's actually part of the read R package. So we should have already installed that and loaded it up. And we will just give it the same name because it is the same name. So it's just student performance.csv, same as above. Go. And let's put this in a variable called read R performance. You can name it whatever you would like. So let's try to run this. We get some feedback, and we now have our read R performance data frame. So we can click it, and this looks identical to our CSV, except you will notice that the read R or tidyverse version of reading CSV files will keep the space between in column names. So if you look at the base read CSV function, it replaces spaces with dots, or periods rather. So that is something to note. There are slight differences between all of these different types of packages. All right. Do also note, since we are trying to, since we do have those spaces in the column name, there is a slightly different way of accessing the columns. So you can put the read R performance and the $, and it should autocomplete for you. So let's put math score. Notice it's not math underscore score, it's just math space score, and you do have to add these little quotes in it. If we didn't have the quotes, R in RStudio wouldn't be able to find the entire math score column. It would just look for something called math, which isn't there. But yeah, slight differences in all of the different packages for reading in data files. All right, so lastly for CSVs, I want to demonstrate that you can actually read in from a URL. So the URL we want to read in from is actually going to be on our R Workshop 3 data. So let's say you wanted to read some data from GitHub, you could kind of navigate there. So in this case, I want that student performance.csv again. So I will click it. And notice that I get a kind of preview of the data. GitHub, at least for this data set, will only preview 300 lines. So we actually want to click this raw button over here. So we can click it. And now we have all of this raw data. And if you look at our link, it's a little long, but not too bad. It does end in .csv. So because it ends in .csv, we can actually load this into R. So I'm gonna copy this link, jump back into RStudio, and I'll just use the base read CSV function here. So I'm gonna call this URL performance, and we'll use the read.csv function. We need to put it in quotes again, and I will just paste that link we copied earlier. And now when I run this line of code, it might take a little bit longer because it is actually going to the internet and grabbing this data, but we now have a URL performance piece of data here, and that's great. We successfully read a CSV from the internet. So you don't actually need to download the file to your local computer. But of course, it's not always guaranteed that this file is going to be on the internet. So it is a much better idea to save it to your local computer. All right, so we read in some CSVs. Probably the second most common is going to be reading in from Excel. So I'll title this Read from Excel. And we will use another tidyverse package here called readxl. So we already loaded that up. And the function to read Excel files is going to be read_Excel. And we need to pass in the file name. In our case, it's that student's performance data set again, except this time it's student's performance.xlsx. So this means it is an Excel worksheet file. So let's store this in a variable name. I'm going to call it Excel performance, just to kind of separate them. And we can read this. And notice we now have this Excel performance data. So let me actually clear out of all of my other data, run this again. And we have our Excel performance data. And hey, looks just like the CSV one. And that is exactly what we want. There are some parameters you can pass into some of these functions if you're not, or if your data set's being read in a weird way, but you can run that help command on functions as well, and they will kind of tell you everything that you can pass in. All right, so we read in a CSV file, we read in an Excel file. So how about we read in a SPSS file? So I'll just title that read SPSS. We will use another package here, which is foreign. You can see it right here. We did load it up. So foreign will actually be able to read in SPSS files for me. So I'm going to call this psych bike because the file that we were trying to read is called psychbike.sav. That .sav means it is an SPSS file. So I'm just going to call it psychbike. And the function we use is going to be read.spss. So I was talking about the fact that you can add different parameters here. So we are going to actually have to add some parameters to this function. So first off, as you may have guessed, is going to be the file name. So psychbike.sav. Second is actually going to be use.value.labels equals, and we're going to set that to true. And finally, 2.data.frame equals true as well. So let me close out of all these other previews. And I will run this and then explain kind of what all of this means. So let's run it. Get a little bit of feedback, that's all right. But we now have this psychbike data set, so we can open it up. And this is what it looks like. This looks good. We can understand the data set fairly easy, and we successfully read in from a SPSS file. So use value labels, we set that to true, because if we set it to false, we'll get the unencoded version. So we can run that again. And now vehicle is just 1, color is 2. So I really don't know what that means. I don't have the original documentation for this SAV file, so I'm clueless to what this really means. So that's why using value labels, setting that to true, is generally what you want to do. All right, and to data frame just means it's going to store the data in the data frame, which is generally what we want. All right, so I actually want to show you one more way to import data. You can actually import from your clipboard. This is a very handy little piece of, or little way to import data. So in our case, we're going to try to find a table on the internet and import some data from it. So I already found a table. It's going to be the Yahoo Finance website, and it's going to be Disney's stock prices. So this link should be in the chat as well, so if you'd like to follow along.
Jarrod, just letting you know you have 15 minutes left.
Great, thank you. All right, so we have a table here. Looks pretty good. We have all of our column names, and we have a lot of rows of data. So as you can see, we could have just downloaded it here, but a lot of tables you can't download. So what you can do is highlight all the data you want. We'll just go back to August 21st, why not? And we'll highlight it, right-click it, and then click Copy, and jump back into RStudio. And we need to actually run a command now. So I'm going to call it, or I'm going to call the variable stocks. I guess it's just one stock, but then I need to run the command read.delim and pass in clipboard. So I am telling R in RStudio, hey, can you please read whatever's on my clipboard and put it in this stocks variable? So let's run it. We now have a stocks data frame. We can click. And hey, this is exactly the table that we copied. We can confirm it a little bit. So October 6th, all of this looks pretty correct. So that is a really quick and fast, easy way to essentially scrape some data from the internet. But you can do this with Excel files. You can do this with pretty much anything that'll copy it to your clipboard. It can be hit and miss if the table is kind of programmed weird on the internet, but test it out. You'd be surprised with how much stuff you can actually get that way. All right. Lastly, with talking about importing, let's say you're importing data and it's simply just not working well. Everything's looking weird. You can't seem to get it by using some of these commands. There is a way in RStudio to import data with a graphical user interface. So you can go to File, Import Dataset, and it gives you a few options. So from text, from Excel, from SPSS, Stata, and so on. So just for example, I'll show you from Excel. You get this wizard that kind of pops up. And here it asks for a file or URL. So you again can put a URL, but I will click Browse. And let's say I want to import that Excel worksheet again. I can just open it. It will actually generate a data preview for you. And you can actually change the data types in this little area. And notice all of the code is automatically generated for you. So you can either click import or copy and paste this little bit of code. There's a lot of different options here, so a lot for you to play with. All right, so I'm going to close out of that. And we've imported a lot of this data, so it's about time that we export a lot of this data. So exporting is a bit simpler than importing. So if we want to export a CSV, we will call the command write.csv. We need to give it the data that we want to export. So in this case, let's export that stocks data frame. And we just need to name it as well. I'm going to call it stocks.csv. Make sure to put the dot and then whatever data type you're trying to export it to. So in this case, we're doing CSVs, so we'll export as .csv. So we can run this. And if you refresh the files pane over here, you will notice that stocks.csv is now in your data folder. We can actually confirm it's in this data folder. All right, so for writing Excel documents or file types, we can use write.xlsx. And again, I'm going to give it the stocks data and name it stocks.xlsx. So this should save it as a Excel worksheet. So we can run this and refresh our files pane. And we now have a stocks.xlsx file. So great. We successfully exported this stocks data frame into a file that you can send to anybody with Excel, and they are free to open and do whatever they would like with it. Finally, we can also export SAV files for people who are using SPSS. We are going to use the package Haven here, and the command or function is going to be called write_SAV. And just like all of the other write commands, we need to type in the data we want to export, stocks, and we need to give it a name. I'm going to give it stocks.sav. So after I run this, I can refresh my file pane here, and we now have a stocks.sav file. So you can send that over to anybody with who's using SPSS. They'll be able to open it up and work with it. So this is a great way to be able to just share data with people who may not be familiar with R. All right. Lastly, when talking about exporting, I do want to talk about exporting plots or charts. So let me create a very quick chart here for you. So I'm going to call the histogram function, and I'm just going to use that built-in dataset mtcars and access the MPG column here by using the $sign operator. And I will run this. We will get a very basic histogram of MPG in the mtcars data frame. And if we want to export it, as you may have noticed, there is this export button. We can click it, and we get 3 options. We can save it as an image. This just saves it to wherever you would like, and you have quite a few options for exporting for image formats, and you can adjust the size and so on, and name it. All right. The other option is saving as PDF. This will just export it as a PDF. I admittedly do not use this option that often, if ever. Lastly, the one I used most often is going to be copy to Clipboard. So this will actually just copy it to your clipboard, and you can send it anywhere that would accept an image. So I've actually sent plots over Discord and Slack this way, and you can copy and paste them into Word documents and pretty much any document. So that's probably what I use the most. So I'll exit out of here. And you can do that with any plot that's going to pop up in this little plots pane here. All right, so we've done a lot of importing, a lot of exporting. Let's talk about some web scraping. So the package we're going to use here is going to be called RVest. So let me clear all of my data here. And let's jump into some web scraping. Let me not kick my headphones off. All right, so what we want to do first is actually install a extension to your browser called SelectorGadget. So the link, I think for the Chrome version, will actually be in the chat right now. But I am sure that they make extensions for Firefox as well. So it should look something like this. So please get this if you would like to follow along. This is going to pretty much allow us to scrape data from the web without any knowledge of HTML. So HTML is what's used to build the web pages on the internet. So you kind of need to understand a little bit about it to be able to scrape data. But if you don't understand anything about it, you can use the SelectorGadget extension, and it is going to help you out a lot. So I use this for pretty much all of my web scraping, so it's fairly invaluable to me. All right, next we want to actually get a page to web scrape. So what I'm going to web scrape is going to be the IMDb 10 worst movies list. So this should be in the chat right now. It is a long link, but that's all right. So we want to scrape all of the lowest rated movies on IMDb, or according to IMDb. There are some things we want to make sure with scraping the web here. So first of all, we want to make sure we're not scraping a JavaScript generated website. RVest alone cannot scrape JavaScript generated content. So an easy way to tell is if the thing is really interactive or kind of loads a second or two after you load the page, that is most likely going to be JavaScript. So it can be a lot of trial and error for web scraping. Secondly, please notice that all of the movies that we're trying to scrape, they all have ratings and they all have years and titles. So this is kind of an ideal data set here. There are no missing values, which is nice for us.
Jarrod, you have about 5 minutes left.
Great, thank you. So what we'll do is copy this link and jump back into RStudio. And we need to create a URL variable and give it the URL in quotes. So very long URL, as I said, but that's all right. We can run this line. We get URL stored. Now we need to run our a command from RVest. So I'm going to call this variable web page, and I'm going to use the read underscore HTML function and pass it the URL of the website. So this read underscore HTML function, it's from RVest. It's going to actually go to that web page and read all of the HTML that is on the web page and store it in this web page variable. So we can run this. It'll take a second because it is going to the internet. All right, we've got it. Not exactly what I was trying to do, but that's all right. So we now have our web page stored in data. So now it's back to the browser, and let's figure out what we want to actually scrape. So I'm going to scrape the title, year, and rating, and I'm going to do it one at a time. So because I don't know much about HTML, like all of you, I'm going to run the SelectorGadget extension, and you should get this box in the lower right-hand corner. And when you move your mouse around, some things should start to highlight. That is good, that's what we want. So all you need to do is click whatever you want to scrape. So I want to scrape the titles, so I'll click the first title. And notice a lot of things start to pop up or get highlighted. So you want to make sure that you only have the data that you want to scrape highlighted. So I don't want to scrape box office or top rated TV. So what you can do, if you don't want something that's highlighted, you just click it and it goes away. And we can scroll through this list and all of our movies, the titles are highlighted. So you will notice an output from SelectorGadget that's called #main space A. So that is the kind of HTML that is associated with the titles of the movies. We don't really know what #main A is, and we don't care too much for now. We just care that it stores the movie titles. So we can jump back into RStudio, and we're going to have to run 2 lines of code here. So title underscore HTML. So we are going to use the HTML underscore nodes function and pass it our web page and the HTML tag that we want to scrape. So that's what we copied earlier. So that is going to be that #main space A, which is where all of our titles are stored. All right, the second line is going to be title and assign it the output of HTML underscore text and title underscore HTML. So that might be a little bit much, so let me explain it. So in this first line, I am getting all of the HTML nodes where this #main A will pop up, which is where all of the titles are stored. And this HTML text function is just going to grab all of the text associated, or grab all of the text that is found in this HTML. So we can run both lines here. And we now have a title variable. So let's run that in the console to look at it. And we have all the titles, which is great. but we also have a lot of spaces and things like that. That's very common in web scraping. It will pop up all the time. You'll have unclean data. So let's clean that really quick. So title is, so I'm just going to select all of the entries in the title that are not spaces. So I'm going to go title and then use brackets to select all of the entries that are not equal to a space. So we can run this. We're reduced to only 100 values, and we can look at title again. And all of our titles are here. Looks pretty clean, except, oh, we still have one that is just kind of empty. So instead of taking all of the titles that are not equal to an empty space, we can change that to just nothing. And run this again. And run title again. And we now have 100 entries that are pretty clean. Very clean, actually. All right, so with just these 2 lines of code and a little bit of HTML swapping, we can scrape the rest of our data. So let's do that. So I want to scrape the year now. So I will click clear, and I'm just going to click the year. And notice it looks like all the years are just highlighted, so no further clicking is needed. We can copy this HTML kind of tag and go back to RStudio. And instead of hashtag main A, it's now going to be .secondaryinfo. Again, we don't worry too much about what that means. We just care that that's where the year is stored. So let me, instead of title HTML, I'm going to put year HTML. And I will swap that down here as well. Instead of title, it's going to be year. We can run this, confirm by looking at the year variable. That looks like 100 years to me. Let's do the same, except instead of year, let's grab the rating.
Jared, you have like 1 minute.
All right, then I'll go a little bit quicker. We're just about done. So I'll clear and I'll click the rating. I notice it's stored under the strong tag. We can copy this. And instead of .secondaryinfo, we can use the strong tag. Instead of year HTML, it's going to be rating HTML. And instead of year, it's going to be rating again. So we can run that. And just to show you guys it all came together, I want to create a data frame. So I'm going to call it badmovies.df and data.frame function. So I'll pass into it the title, year, and rating. So we have this bad movies data frame. We can open it up. Let's actually confirm we scraped the right data. So disaster movie 2008 got a 2.0. Codename KOZ 2015 got a 2.1. All right, so it looks like we successfully scraped some data from the web. So I will call it there for the programming. So let me jump back into the presentation so we can look at our outcomes and make sure we accomplished everything. So we explained how to create a GitHub repository and collaborate with others. We loaded and looked through some of the built-in data sets in R. We imported the various data types into RStudio. We did scrape data from the web using SelectorGadget and RVest, and we did export and save some output data. So I actually did create a video on how to install Git and GitHub and get it linked to RStudio. So that will be coming in an email soon. All right, thank you very much. Please follow all of the social media for both the AMI and the CCIDM, and please feel free to connect with me on LinkedIn. Thank you very much.